We're bringing out school student teams from 254, Lockdown is the name of their team, and Citrus Circuits. Go ahead and clap. They're smarter than all of us. So I'm going to let them show you guys their robots, but the general premise is this. They compete in a competition called First, and they get rules in like January. They're like, okay, here's how the game is going to work. In this case, it's stacking blocks, right? And you have to build your robot. They built it all themselves. They programmed it all themselves. And I'm going to kind of toss it to them to tell you about what they've been working on. So why don't you guys take it away? I'm just going to stand over here.
Yeah, so okay, we are Team 254, the Cheesy Poofs out of Bellarmine College Preparatory in San Jose. This year we had a really amazing season. We won the 2018 World Championship, which was our 4th World Championship win throughout our team's history. And in addition to that, we had a 53-0 record throughout the season. So overall, we had a lot of success this season. As for the robots, these were designed for the 2018 FRC game First Power-Up. The premise of the game is to stack these yellow cubes here on elevated seesaws throughout the field, and you score points based on how much time you possessed these seesaws such that they're tipped in your favor.
So I can go over the match structure that we play in. So every match that we play is 2 minutes and 30 seconds long. The first 15 seconds are autonomous, which means that the robot is following strictly pre-programmed instructions. But the 2 minutes and 15 seconds following are driver-controlled, which means that our driver and our operator are working together to control all the subsystems of the robot so we can score in an efficient way.
Yeah, so I'll talk a bit about autonomous. So we've got a variety of sensors located on our robot to help us navigate around the field and score during the autonomous period. So we've got a gyroscope and encoders on our robot to help localize our robot on the field, encoders on our elevator and our wrist to determine their positions, and 2 IR sensors located in the carriage there to see whether we've got a cube or not.
All right, and without any further ado, we're going to demo our robot. So,
like my little protege.
Yeah, thank you. So it is 28 inches wide, 33 inches long, and 54 inches tall. It weighs around 150 pounds. So we're going to start off by enabling the robot. And we're going to pivot out our wrist first, which is this system right here. And then it's going to drive forward, and it's going to intake in this yellow power cube, as it's called. It's going to stow the power cube back inside the robot. It's going to elevate up around 2 feet. And hopefully I can catch it as it spits it out back to me. And now it's going to do a quick turn around really quickly. It's going to pivot the wrist back out a little bit. It's going to intake in the cube. It's going to stow the cube back inside the robot. Okay, we're having a few problems right now.
Okay,
I think it's
you
the
guys are in the
Wi-Fi.
splash zone if I need to crowd surf. Just FYI.
All right, and now it's going to elevate up, hopefully, to around 6 feet in the air. Elevate up to 6 feet. Yeah, some Wi-Fi issues, sorry about that. And then it's going to drop the cube. And then in the last 30 seconds of the match, that's when we can actually climb up a bar with 2 robots on us. So what's going to happen is that in the last 30 seconds, our hooks are going to deploy out, which are these blue kind of pieces right here. We're going to elevate up our elevator. We're going to elevate up. And then we latch onto a bar, which is a 2x2 box extrusion. And then we deploy down the forklifts, which are these pieces. Sorry? Oh, sorry. Yeah, so there's a lot of Wi-Fi issues right now, so that's why it's not working out too well. Apologize about that. But yeah, essentially, these 2 black forks deploy down like that on both sides. They are made of carbon fiber rods, which are 5/8 OD, and they're solid. A robot can drive up onto these forks when these are deployed down, and then it can climb up, lifting that robot with it. Yeah, go ahead. Yeah. And then a robot can climb onto these forks, and then they can be raised up into the air. So now I'm going to hand it off to Team 1678.
Yeah, who feels good about themselves? Okay.
So hi, we are Team 1678 Citrus Circuits in Davis, California. It's about an hour and 30 minutes away. Yeah, so our team has about 98 students, and we're all broken up into different technical sub-teams. So all of our students have the opportunity to learn a lot of different kinds of, learn their different technical expertise. So some of our students learn CAD design. Some of our students learn how to program. Some of our students wire the robot and do pneumatics. And then some of our students do the business and finances section. So in addition to all of these technical skills, we also learn a lot of soft skills, managing this team, coordinating projects, coordinating deadlines, making sure that everything is up and ready for our competitions. This year we competed and won 3 different regionals across California and Utah, and we competed in the Houston World Championships alongside Team 254, placing 3rd place after getting beat out by them. Yeah.
All right. So something that I find really interesting about the first competition is how we have a very similar or the exact same challenge every year between teams, but teams find very different ways to approach the same problem. So some of the elements between the robots are very similar. They both have very similar degrees of freedom, one linear elevator and one sort of pivoting wrist. But after that, the similarities really stop. So whereas 254 chose to hold the cube inside of the robot, we sort of hold it extended out, cantilevered out. But that system is actually fairly similar. Something that's very different from how 254 actually runs their robot is the climbing system. So 254 chose to use forklifts. We chose actually to use something that deploys off of the side of our robot. That's this big plate-looking thing. It's actually designed after an airplane wing, which makes it very light, and it's got a bunch of holes to just reduce the weight even further. So we're actually going to do a quick demo of that right now. We'll take it away. So, all right. So yeah, this hook extends and it latches onto the bar, which is the rung that you're climbing on. We don't have a bar, obviously, but we're going to hold that real quick. So Amanda, can you hold it? Yep. Okay. And then the hook actually deploys as well as this ramp. I don't want to have that drop on the ground and make scuff marks, but a robot is actually able to drive onto this, and the whole thing winches up via these 3 strings. So that's sort of how the climbing system works, which is a very different approach to the approach that 254 took. And both approaches were actually very successful. It's just interesting that very similar design constraints can produce very different outcomes. All right, so we're going to demo the rest of our robot really quick, and then we're going to. Okay, so. So, like I said, 2 of the degrees of freedom on the robot are very similar. It's got an elevator, moves up and down, a wrist, moves back and forth, and an intake that sucks the cubes in and prepares them for actually scoring them. So I think we're actually having some of the same communications issues just because there are a lot of Wi-Fi interference in this venue, but it does communicate over Wi-Fi. So
Is that an Xbox controller?
Yes, so it's controlled using an Xbox controller, a joystick, and actually a Ferrari wheel. So we've gotten a lot of questions about that. But yeah, that's what Livy here uses to drive the robot during matches. So yeah, it basically lifts up, and it can score it. So Amanda, could you pick it up? So as you can see, a lot of the scoring is very similar between the robots.
Can I ask you guys what the biggest challenge was?
So yeah, designing a robot in 6 weeks is actually the biggest challenge in and of itself. So we have 6 weeks basically from initial conception to finished product here. And you can see that our robot doesn't look like the prettiest thing. It's basically a consistent prototype because we're constantly working to improve it, and we're constantly seeing what other teams like 254 are doing and working with what we see to figure out how we can make our robot better. So there's a lot of constant reiteration upon the design that we have.
What first got you guys, and this is for both teams if you guys want to spread the mics around, at what point were you like, oh, I want to build a robot? Like, where did your inspiration come? These guys are 14 to 18, so at what point did you get into it?
As for me, my sister majored in computer science in college, so I kind of had that inside perspective as like what engineering was, and as a result of that, looked into the robotics program at Bellarmine, which is the high school that I was going to be attending, and just kind of fell in love with the program right away. I'd always been interested in engineering, sort of, but like wasn't really sure, but definitely through the robotics program, and that the interest that my sister instilled in me, I was able to like find robotics, and as a result of that, like really solidify my interest in engineering.
Big sisters
I have
are
a
the
pretty
best.
similar story, and it's something that you're going to hear from a lot of first students. I wasn't sure if I wanted to do it. I came to one meeting, and I was hooked. I was initially a bit wary about the time commitment. Apparently, all those concerns have gone out the window because now I spend 60 hours a week working on robots.
It's more than I spend at work.
So I'm actually kind of an exception among this crowd. I don't actually work on the robot. I do a lot of business, PR, finances, as well as administrative and management tasks. I kind of got part of this program because my friend was part of it. Kyle here also dragged me into the program. And I just had a really great time, even though I wasn't working on the robot itself. The culture of FIRST and just the atmosphere and the working environment were just really, really engaging, and I found a really great program. So even though I'm not learning the technical skills to build the robot, I've been learning a lot of the soft skills in order to make the program run as smoothly as it can.
And personally, it's super cool because we can build these robots within only 6.5 weeks, which is, it's great to do as high school students, and just being able to have that chance to do that and to really explore different kinds of, of engineering doing this. It's just an awesome opportunity, and that's what really got me hooked.
And just quickly before we run out of time, like, where do you guys see yourselves in 5 years? Just so I know where to serve the coffee.
So yeah, I'm going to be majoring in computer science, and I'm hoping to actually go into working with robots, research potentially in control systems. That's sort of where my interest lies.
I'm actually a freshman this year, so I haven't totally thought it through yet, but I'm definitely going to be interested in software engineering and anything related to that.
Awesome.
So I'll be doing EE in college, and then hopefully after that I can help design chips and processors, which can be embedded inside these robots.
I really love space, so I want to major in aerospace engineering and then go into the industry working on propulsion at a private space company.
I'm going to be studying mechanical engineering in college, and in the future, I hope to continue working in the robotics field because this stuff is super cool.
I'm going to study CS and controls in college, and I hope to work in the robotics industry as well, because it's really fun.
I think you're next.
Yeah, okay. I'm going to be studying anthropology and art history, and I hope to work in a museum in the future.
Yeah! That's my girl. All right, like another seriously massive round of applause for these young people. Go ahead and take it away. Going all the way that way. And as they work to get this off and I work to repair my ego, I'm excited to announce that we do have one other high school team that is in a different competition. So FIRST is its own organization competition, and our next team is involved in the pie competition. So with that, does Hercules High School, you guys want to come on out, show us what you're made of? Yeah? Just you? Oh yeah, you do need a mic. Can we have that back?
Hello there. I have some slides, so hopefully they appear somewhere. But I'm Jesse. I'm a student at Cal. I participated in Pioneers in Engineering when I was a high school student for 3 years, and I've done it for 2 years now as a college student on the staff end of things. What Pi is, essentially, is a robotics competition that we hold here at UC Berkeley. We think it's important to consider FIRST robotics and Pi from a broader perspective. We want to show a whole bunch of students the joy of robotics like I got to experience in high school. And on top of that, there are some interesting numbers we have. By 2022, the US will have a shortfall of 1 million STEM grads. We need to train more engineers from all over to work on the coming developments in robotics. Plus, we need to find the next Ken Goldberg or Peter Abeel.
Look nice.
In terms of robotics education, we are doing pretty well. The South Bay had over 30 varsity teams this year, including our friends from Team 254. However, in contrast, there are fewer than 10 RC teams in the East Bay. We're hoping that Pi can cover some of these gaps and further spread STEM education throughout the Bay. So, this is the challenge we set for ourselves. We plan to bring robotics education to everyone. So, the two challenges we face in implementing that are limited financial resources, because, robots are not cheap. And the second is limited expertise in a highly technical field with very high barriers to entry. Our solution in Pi is a college-run robotics mentorship program. How does Pi tackle the challenges we see? The first challenge of limited financial resources, we solve this by fundraising all the student expenses. We also build the robotics kit in-house to save costs, and it allows us UC Berkeley students to actually apply some of the knowledge we learned in the classroom to real-world endeavors. The second challenge of limited expertise, UC Berkeley students act as personal mentors for each team. They pass down a lot of the knowledge they've learned in college. This is a great dynamic, too. Younger and more relatable faces encourage more high school students to get involved in robotics. Okay. Pi served over 20 high schools in the East Bay this year, which we're really proud of. We got to work with some really great people. With those teams, plus the FRC teams in gray, more local students than ever have been able to get a great high school experience. Now, I'm happy to introduce one of the high school students, Janvi, from Hercules. She's going to talk about her Pi experience and show us her robot.
Hi, everyone. Just out of curiosity, do you guys remember your prom day? Because it's a pretty memorable day, isn't it? And here we are. Today is our prom day, but even though prom is important, Pi Robotics and just robotics in general is even more important to us. So here we are in front of you guys. And the rest of my team will be assembling the setup for the robot right behind me while I'll be talking about our journey. So I got my first glimpse of engineering at a summer program on a university campus, where all the other students from schools had computer science and robotics classes, 3D printers and machine shops, and there it felt as if engineering was out of my reach. So when I got back to Hercules, I decided to try and get some of those resources at my school. But despite repeated requests to the school administration, I wasn't able to convince them. Instead, after a rigorous cycle of fundraising and grant writing, we were able to secure barely enough money to compete in FTC, the scaled-down version of FRC. It became quickly clear here that we were at a huge disadvantage, coming from an area that had no support for engineering. And it still felt that engineering was out of our reach. But then we joined Pi Robotics. And our mentor, who was a UC Berkeley student, was just a few years older than us. He had been president of his high school's FRC team and was incredibly knowledgeable in all areas of tech. And working together day by day with him, our robot began to operate more consistently, and our members became more like family. We built our own gearbox and learned how to program in Python. We designed, builded, and tested our robot over many iterations until we arrived at its final form. And for the first time, it felt as if we had done real engineering. And we ended up winning first place that year in Pi Robotics competition. So with the help of Pi, we have been able to create an actual sustainable robotics community for the first time in our community. We've been named Club of the Year at our school, and we've given presentations at our city council meetings called upon by our mayor. And proudly, we have been able to plan and host our own robotics outreach programs for younger kids. We created and raised money for a 5-week program called Build-A-Bot, where we taught middle schoolers the basics of building robots. We mentored FLL junior teams in all 3 of our local elementary schools. We wanted to give the younger kids in our community something that we never had, an early exposure to engineering right within the community. And so one day, they'll be able to come to the high school's team and outperform our robot much more than we could ever expect. Thank you. And now it's time for our robot demo. Yeah, could you please just all go on airplane mode, every single one of you, so we can get the network issues working here? Exactly. Well,
There we go.
maybe if everyone happened to turn off the cell phones, then maybe we could be able to play fetch with the robot here. But until then, we'll just
I
have
love
to see.
the attitude, though. You're like bringing it. Okay, we're getting there.
It's getting somewhere. Yeah, the Wi-Fi is the robot just doesn't like it.
It's okay. We believe that you guys are really good at it. I do, at least. Do you guys believe it? Adults are stubborn. It's the thing. Yeah, okay, so we are out of time, but we really appreciate you coming to hang out with us on prom day. And when you look back and you have billions of dollars, you're going to be like, cool, that was the right choice. So another huge round of applause for our genius youth. Good job, guys.